So we'll look now at definite integration, and this is where we have limits. You need to make sure you're very careful with your notation here. So our first type of question would just be evaluate. Okay, so this is evaluate for part A between 1 and 3 of x cubed dx. So you can see this is our lower limit down here, the 1, and the higher limit, the upper limit is here 3. You can see 1 is smaller than 3, and that's always going to be the way with your limits. Now, whenever we integrate, we change to squared brackets. So integrate the x cubed, you get x to the power of 4 over 4. And we move our limits to the right-hand side. Okay? Now, to evaluate this, we put in the top limit where we see x. So that's 3 to the power of 4 over 4. And we put in the bottom limit. So that's 1 to the power of 4 over 4, and we subtract. Okay, so it's always the top limit take away the bottom limit. So that's 81 over 4 take away a quarter, which gives you 20. And notice now we don't have a plus c here, and it's because if we had a plus c in our first line here, when it came down to putting in the limits, we'd end up with a plus c minus c, and it would just cancel it out, so there's no point in putting a constant of integration in now. Our second one then, we're integrating between 3 and 5 of x minus 1 dx. Again, notice your lower limit 3 is at the bottom, upper limit 5 at the top. So when we integrate, we go to square brackets. Integrate x, we get x squared over 2. Integrate minus 1, we get minus x. Remember, we don't need the plus c. And we move our limits to the right-hand side. Then we put in, where we see x, we put in our top limit. So 5 squared over 2 minus 5. And we subtract then the bottom limit. So 3 squared over 2 minus 3. So that's going to be 15 over 2 there, minus 3 over 2, which gives us 6. So definite integration is important because we use it to find the area under a curve. So if we have a curve here and we're finding the area between A and B under that curve, and let's call the curve f of x the function of x, well, this shaded area is the integral between A and B of f of x. Okay, so that's why definite integration is so important. And just a wee thing to remember when we're doing this, if you're finding an area that's underneath the x-axis, you end up with a minus sign in your answer. Okay, and we'll go through that again in a wee second. So our second example then, find the area enclosed by the curve y equals x upon 4 minus x and the x-axis. So the first thing you're going to do is sketch the curve. Now we're not looking for a detailed sketch here where we're finding turning points and stuff like that. It's just knowing the basic shape and where it's crossing the axes. Okay, so whenever y equals 0, we have 0 equals x upon 4 minus x. So x would be 0 and 4. We know the basic shape. If you multiply that out, we get y equals 4x minus x squared. So it's a negative quadratic, so we know it's going to be in that sort of shape. So we don't need to worry about turning points and that sort of thing. So mark on 0 and 4. And our graph is going to look something like that. And that's the area that we're trying to find. So now this area is above the x-axis, so you would expect it to be positive. So we're integrating between 0 and 4 our curve, and I'm going to use the multiplied out version, 4x minus x squared. So we're integrating, remember then it goes to square brackets, add 1 to the index, you get squared, and then divide by 2 would get 2x squared minus x cubed over 3, and this is between 0 and 4. So put in our top limit, so 2 times 4 squared minus 4 cubed over 3 minus, and then put in our bottom limit. Now, when you put that in, we're just going to get 0. So it's just the first bit that we need to do then, and it turns out to be 32 over 3. Number 3 then, find the area between the curve y equals x upon x minus 2 and the x-axis. Again, we're going to sketch the curve. So when y is 0, we get that x is either 0 or 2. When we multiply that bracket out, we get x squared minus 2x. So we know it's a positive quadratic, so we know the general shape of it. So this is 0 and 2, and this is the area that we're looking for. So we should expect it's below the x-axis, so we should expect to get a minus in our answer. So our area, we integrate between 0 and 2, x squared minus 2x dx. When we integrate them, we go to a squared bracket. So x cubed over 3 minus, add 1 to the index, you get x squared, and then divide by 2 would cancel out your other 2, and move our limits over to the right hand side. Put in our top limit, and then subtract our bottom limit, and we would just get 0 when we put in the bottom limit. So when we work this out, we'd get minus 4 over 3. Now, if this was just an evaluate question, like the first example, you would leave your answer as minus 4 over 3. Because it's find the area, you would then say, therefore, the area equals 4 over 3. And if you want, and sometimes it does ask you in an exam, what's the significance of the minus sign? So it's below the x-axis. Our last part then of definite integration, we also could be asked to find the area between a curve and the y-axis. So an area like this, it's shaded. So to find the area here, it's the integral still of from a to b, and this time it's of x dy. Okay, so we'll do one example of that. So find the area enclosed between the curve y squared equals 9 minus x and the y-axis. Okay, so again, the first thing we're going to do is sketch the curve. So when x is 0, y squared would be 9. So that means y would be the square root of 9, which remember would be plus and minus 3. And when y is 0, x would have to be 9. So that's 9 there. Apologies that this isn't completely drawn to scale or anything. Minus 3 and 3 are on your y-axis. So the area that we're looking for is this area here. So now what we need to do, there's an extra step in this. We need to rearrange our equation so it's x equals. So we're used to having an equation y equals something in terms of x. Now we have to rearrange to give x equals something in terms of y. So it's fairly straightforward. Bring the x over to the right hand side, bring the y squared over to the other side, and we get x equals 9 minus y squared. So to find the area, we integrate between minus 3 and 3 of 9 minus y squared. And that'll be dy because it's y's that we're integrating. So again, go to square brackets, 9y minus y cubed over 3. From this part is exactly the same. And move your limits over to the right-hand side. So it will be putting in the top limit 9 by 3 minus 3 cubed over 3 minus 9 by minus 3 minus 3 cubed over 3. Just be really careful with the minuses and pluses then. So we get 18 minus 18. So we've got 18 plus 18. So it gives us that the area is 36.